Okay, so we've got basically the header of our program all ready to go, our safety line, our setup information, and now we're ready to go into our milling operations where we're going to mill this square and we're going to mill this circle. So let's go ahead and get into that. And we'll jump back over to our program where we left off here. There we go. Okay, so let's just put a comment in here telling it what we're going to do. Mill square pocket first. We'll just put that, mill square pocket first. For the tool, we're just going to take this tool setup information right here, and I'm going to copy the tool 4 info and paste it there again. And then we'll go ahead and get this tool to the spindle. T4 M6, right? A T4, that's tool 4 with an M6 telling it, do a tool change, move that to the spindle. We're going to go ahead and do our M1 optional stop, and we're going to verify our correct tool. Okay. You know, the first setup, we always want to take a look and just make sure that tool's the right one for the job. After we've got the tool verified, now we will go ahead and bring the tool down to a location for a start point. So that being said, let's go ahead and take a look at our plotted out points here for this part. Okay. Here's the contour points. Like I said, we're going to do the contour first, and then we are going to do the holes. So I got my holes up here, I got my contour here. Now this is straight out of the answer key. Notice that it's got leading zeros in here and there's no point after the zero. And I know some people have reached out to me and said, hey, I didn't put my decimal point. I put it in the instructions. You got to have your decimal there. Okay, the machine requires it, so I require it. So make sure that if it's a 0 is your location, it's 0 point. And any of the rest of them, no trailing zeros. Okay, so like this 0.750, that 0 is not necessary. So we don't need to put those trailing zeros on there, or the leading ones for that matter. All right, so moving forward, what we're going to do is we're going to move to position 1 right here. Okay, that's where we're going. So I'm going to tell it here, I'm going to do a G90, G54, G0 to X0, Y.875. Okay, everybody good there? That's that position 1. That's where we're going to. Okay, going to this point, this position 1 right here. All right. All right, so that's going to be a good place for us to check our tool out. So that's what we're going to do there. We're going to go ahead and get to that location. We're going to tell it that this is our start position. And we're going to check our tool. So that's what we'll do now. We'll tell it, hey, we're going to do a G43. What's that? Tool length compensation, right? And along with the G43, we've got to have an H4. Tool 4, tool length 4, H4. So we have to put that in there. We'll do a G1 down to 2 inches above our part, and let's just set the feed at like 50 inches a minute. Then we'll do our op stop, and we'll verify tool length. Okay, that looks good. So once the tool length's good, and we've checked it with our 1, 2, 3 block or whatever we might use, now we can go ahead and tell it to turn the spindle on. So S7750 M3. That's telling the spindle to turn on clockwise. So that's happening. We're good there. We're still above the part, so at this point, even if I go to my draw screen and try to draw it, nothing's happening yet. Okay, we can't see anything. We're just sitting up here above the part right now. That's all we've got going on. But no fear, a couple lines from now, we're going to start seeing some activity. So let's go ahead and we're going to plunge on down to 100 thou above the part and turn on our coolant. And then we will go ahead and plunge to our depth. So we're going to do a Z minus 0.0625, minus a 16th, Z minus 16th. And I'm going to slow the feed rate down. So my rule of thumb for plunging in material, who remembers it? Probably no one right now. So the rule of thumb is your contour feed rate, 25% of that, or 10 inches a minute, whichever one's less. So in this case, 10 inches per minute since 23 is what it calculated to. So I'm going to calculate to 10 inches per minute, and this is just a safe plunge feed rate. Plunge to depth for square contour. Alright, now if we draw this, we should see it has plunged into the part right there, down the 16th deep. Alright, so from here what we're going to do is we're basically going to work our way around this part. Okay, so the next move, we're going to go straight to the left. Okay, we're going straight to the left on this part. And if we look at our coordinates, open those up again here. Okay. If we look at our coordinates here, they are basically telling us that we're going straight over, we're staying at the same y, but we're coming straight over to x minus 0.75. So we're doing a G1, x minus 0.75, and we can bump our feet up to 93. And that gets us to position 2. Draw that. There's our mill move. Now we're milling an arc, right? We're going to basically be doing a corner now. So if we take a look at our part, we see here we're to this point right here, and now we've got to make this corner. So that's going to be a counterclockwise arc, so a G3. So that's what we're going to plug in here. We're going to do a G3, going to our next position. So our next position is x minus 0.875, y 0.75. This is position 3. So x minus 0.875, y 0.75. And then when we look at that, we need to decide, are we using an I or a J? Okay, what's our value here? Well, the start of rotation, when we look at this part, okay, the start of rotation is up here, and from the start of rotation to the center of rotation, it's in the negative y direction. Okay, so I'm good with that. That means that it's going to be a negative J since it's a y value. And then the mount is basically the radius of the corner minus the radius of our tool, because we're on the inside of the corner. So 3750 minus 0.25, the radius of our tool is a 1/4 inch, so we would subtract that from the actual radius, so it's going to be a J minus 0.125. J minus 0.125 here. That's going to get us to position 3. We draw that. There is our corner. Now we need a straight linear move coming down to position 4. So if you look back at your part, you'll see it's going down to G1 down to y minus 0.75. Our x is not changing. We have to make sure we put our G1 there. If we don't, okay, if we put it there, everything looks good. If we forget it, try to draw this, we're going to get arc out of tolerance error. And that's all it is. It's going to jump to that block, but you got to recognize that I forgot to go back to linear. So you got to switch it back to linear. Our move to 0.5 is another counterclockwise, G3. Going over to x minus 0.75 and down to y minus 0.875. And then this time, if we take a look at our part, okay, if we take a look at our part now, we're starting right here. Okay, we're starting basically right here in this area, and the center of rotation is straight to the right from the start of rotation. So that's in the x positive direction. Okay, it's in the x positive direction, so that's going to be an I positive, and once again it's going to be 0.125. The radius, subtract the tool radius because we're on the inside of it. So Go back to our program. And we're going to have an I 0.125 here. Can draw that. And there is our next corner. Going to tell it from there. We're going straight across again. So G1 over to 0.6. So to X 0.75. There we are. Then we got another G3 going to 0.7, so X 0.875, Y minus 0.75. And this time we have a J 0.125 because from the start of rotation to the center of rotation, it's in the positive Y direction, 125 thousandths. So that's a J 0.125. Look at that. We should have our next corner in. There we are. Looking good. Couple more moves. We got to go back to our G1 here. Up to Y 0.75. That's position 8. And then another G3 to X 0.75, Y 0.875. And this time it's going to be an I minus 0.125. Because from the start of rotation to the center of rotation, it's in the negative X direction. So since it's the X direction, that's an I. It's a negative, and then the radius, subtract the tool radius, 0.125. And then from there, we'll do a G1 right back to where we started at X0. And that gets us to position 10. If we look at this, we have our completed square. Okay, so that looks good. Now, pretty much it's just a couple more lines of code to go ahead and mill this now. So let's go ahead and perform the milling operation for the circle. I guess I should say that. We've already milled the square, now we're going to mill the circle. The first thing we got to do is we got to go on down to depth. So this is going down to G1 down to Z minus 0.125, another 16th deep, and I'm going to slow the plunge feed rate to 10. Plunge to circle depth. If I look at my part and draw this, you see here I've plunged on down deeper into my part. Okay. And then it literally takes one line of code here. We're telling it a G3 because we're going to go counterclockwise. We're going to start and end at the exact same position so our X and Y's aren't changing, so we don't have to put any of those in. All we've got to do is tell it the direction we're rotating, and we've got to tell it our I or our J value. So let's take a look at this part here. We're starting right here. This is where we're at. Okay, so it's from the start point to the center point of rotation. So if this is the start point, and that's at Y 0.875, to the center of rotation, which is 0, it is in the negative Y direction. So it's a Y or a J negative 0.875, because that's the distance from the start to the center. 0.875. It's in the Y negative, so it's a J negative 0.875. You guys don't want to see me again. All right, so it's a J negative 0.875. And this is mill circle. Now that's the one thing you do need to know. Anytime we do a full circle like this, you can only use I's and J's. Okay, you can only use I's and J's, which is what I want you to primarily focus on right now. Later, I will teach you how to use radius values a little differently, but right now, I's and J's in all your programs. So if we look at this, there's our circle milled. Looks good, doesn't it? Now we just got to come up out of the part. So we could also, if we wanted to, we could bump the feed rate back up to 93 to mill the circle. And then I'm going to tell it to come up 100th thou above the part. And then, actually, let's go 2 inches above the part. And we'll shut the coolant off. And then we'll tell it, hey, let's go ahead and bring our spindle up to the home position, G28, G91, Z0, and we'll shut the spindle off. And then we'll go ahead and bring this part to us so we can take a look at it. It's going to bring it to the center. Move home through reference position. Okay, so that has our part milled. So we can draw that, and that looks good. And what I would recommend you do now is definitely go up and save your file if you haven't saved it yet, because we're ready to go ahead and plunge the 1/8 inch holes. So let's go ahead and do that. I'm going to go back up to my program at the top. I grab tool 1's information. Then I'll come down here and say we're going to plunge 1/8 inch diameter hole pattern. And then we will bring tool 1 to the spindle. So what I'm going to do is I'm going to come up here and I'm going to borrow all this information down to right here. So I'm taking from tool 4 down to the coolant getting turned on. I'm going to copy that. I'm going to paste that in down here. Once I've pasted it in, I'm going to modify. So T1M6, G40, or the G90 start position, that's the same spot. You know, that first hole's in that same position, so we're good there. We're at hole 1 position. So I can tell this hole 1 position for the tool check. Now on the tool check line, what do we need to change? Our H value. That's right. So we'll change that to H1. It's going to come down and check the tool, and then it comes down to 100 thou above the part, which can also be called the initial height, because we'll use a G98. So in between each hole, it raises all the way back up to 100 thou above the top of the part. If we set our retract really close to the material down in the pocket and it doesn't retract up high enough, you take the chance at clipping the corners of the part as it moves from hole to hole. So we got to be careful with that. All right, so now that we're at our initial height, we'll go ahead and we'll do that. We'll tell it we're going to do, hey, we're going to do a G81, and we're going to move to the initial height between holes. So it's a normal drill cycle with the G98. Once we got that in there, we'll tell it, all right, we need to go through the part, so we can set our Z minus 0.2, I don't know, let's do like 25 thou breakthrough. So we'll do a Z minus 275. Okay, looks good. All right, now that we've got that, let's go ahead and let's tell it our R plane. I'm going to set the R plane down closer to the material so I'm not drilling from way up above. So I can set my R plane down in the part minus 100 thou, minus 0.1. Because where the holes are drilled, that's already 125 thou deep. So there's no reason to start from way up above the part with the feed motion. We can start 25 thou above the material down in the part. We're going to break through, so we don't need to, there wouldn't be any dwell anyhow because we're using a G81. And then let's set our feed rate for this tool, F1. Okay. And if we look at it now, we should be able to see the first hole there. And there you can see where the feed started from above the part. Now, make sure my rapids are turned on here so you can see these. Okay. You can look at the rapid there, and you can see that it rapided from here to here, and then the blue represents the feed down through the part. It broke all the way through the bottom, so that looks good. Okay, so let's go ahead and add in our other locations. We take a look at our locations. We're going straight over to negative 0.875. Oops, that is an X value. Let's put that in there. X negative 0.875, Y0, hole 2. and then x0, y minus 0.875, hole 3, and then x 0.875, y0 for hole 4. Both the x and the y change each time, so you have to have those in there. And then we can do a G80 to cancel the can cycle, and then I'll wrap it up above the part, and I'll shut my coolant off here. Okay. Notice up here I did not rapid, and the reason I did that and just fed up to 2 inches above, essentially, and we could do this a little bit quicker. Let's tell it just to go up to Z.1, and then we could wrap it here. But I don't want to wrap it from depth out of the part because I don't want to leave a mark on the part. That's usually what I'm trying to avoid there with that feed move out of the part. So down here, we're ready to wrap this up. If we take a look at the program, we should be able to see all 4 holes drilled. Looks good. You see it's wrapping up above the part between each hole. And that's what I was talking about. If we change this to G99, that's going to say go to the R plane, which is going to be -0.1. And it may not hit, but just out of my comfort, yeah, it does. So you see how close that comes to that wall right there? Okay, that's rapids through there. That's my 1/4 inch or my 1/8 inch end mill just got broke. Okay, when it rapids across there with it down in the part, that's my 1/8 inch end mills broke off right about there. It just doesn't show it. I've got to recognize that with the lines as I look at the part. So we want to make sure that's a G98. That way we don't have any collisions. Then we'll do our G28, Z0, M5, our G28, X0, Y0, M9, and last thing, M30 at the end of our program. And that is Lesson 8, Part number 9. So double check all of your program, make sure it looks good, make sure you have it saved, and then you can submit this program on Blackboard for grading. If you have any questions, please email. Have a good day.